All right, what's up, Math 8? Welcome to one of my favorite lessons for this class. Today we are doing Slope-Intercept Form, which is lesson 3.4. All right, so for Slope-Intercept Form, we're really just building on what we did in 3.3. All right, so 3.3, for those of you who don't remember, was y equals mx. All right. Or also direct variation. They're the same thing, right? So this one, we've got y equals mx, but then we're also adding another part to it. Okay, so we'll start out just with looking at this definition we have right here. So the y-intercept of a line is the y-coordinate of the point where the line crosses the y-axis. All right, so they have an example right here for us. Okay. If you look at this little graph, here's our graph, our line for it. All right, so it's right here. Okay, our y-intercept would be where that line passes the y-axis, which is right here. All right, so when it crosses that line, that is our y-intercept. All right, so it's really easy to remember because it literally intercepts our y line. Okay, so that's what B is going to stand for. All right. Okay, so that is pretty much it for that part, and we're going to go ahead and move on here. Whoops. Hold on. All right, there we go. So we're going to go ahead and move on. All right, so like I said, this is the same as what we did in 3.3 with y equals mx, but now we're adding a new part to it. All right, so this is called slope-intercept form, as we see right here, and slope-intercept form is y equals mx plus b. All right, so again, it's just this part, the same thing that we've been looking at in 3.3 and a little bit in 3.2 as well, but now we're adding a b. All right, one thing to note, okay, is that in slope-intercept form, these are not proportional. All right, unless your b is 0, slope-intercept form is not proportional. All right, that's just one quick thing just for you to know. All right, so we'll go ahead and look here at example 1. State the slope and the y-intercept of the graph. Of the graph of the equation y equals 2/3 x minus 4. All right, so as a reminder, our equation is y equals mx plus b. All right, again, m is still your slope. All right, and again, this would be a great thing to have written down. All right, the only thing that's different now, that's new, is that b is your y-intercept. So that's where it will cross the y-axis or intersect with the y-axis. All right. So those are your two parts. Okay, so our slope, if we look at this one, our slope would be 2/3 because it's plugged in for m, as you can see there. And again, your slope is always attached to the x. All right, and then your y-intercept, I'm going to abbreviate it as the y-int. All right, your y-intercept is b. All right, remember it also keeps this sign right here. Okay, so your y-intercept for this one would be -4. All right, and that's really it for as far as the format of the slope-intercept form. Okay. So hopefully you understood those. Go ahead and I want you to try out got it problem A, got it problem B, and got it problem C. So we're really going to make sure that we know how to do these because they are very important going forward in math. All right. So once you've done those examples right there, we'll go ahead and move on. This is still on page 200. We're looking at example 2. So we have, write an equation of a line in slope-intercept form with a slope of -3 and a y-intercept of -4. Okay, so for this one, we still have y equals mx plus b. All right, that's an extremely important thing. I know I've been saying it a lot already in this video, but that's just an extremely important thing to keep track of. All right, make sure you know slope-intercept form is y equals mx plus b. All right, so we have that formula right there. All right, and then we need a slope of -3 and a y-intercept of -4. All right, so I'm going to go ahead and I'm going to plug those in. So y is not going to change. And then it says a slope of -3, so -3 goes in for m because m means slope. All right, x also doesn't change. All right, and then a y-intercept of -4. Remember, that goes on the sign. So that's our y-intercept. Remember, b is our y-intercept. Okay. Now, one thing I do want you to notice here is that y and x, whenever you're writing an equation, those two don't change. Okay, those stay as y and x. And the reason for that is you want to be able to graph it like we have here in number 3. You want to be able to graph that whole line, and you don't want to be confined to just one x value, right? So if you said x is 0, then you're confined to this being the only point on the graph because it's the only place on that line where x can equal 0. All right, so you want x and y to stay as x and y when you're coming up with your equation. All right. All right, so I went ahead and I wrote that right here for you. So if you want to write this down, it would be a really, really good idea. All right, and that'll help you to remember that a little bit. Okay, so once you've got that written down, I'm going to move on. So go ahead and pause the video so you have time to write that down, and then we'll move on to the next thing. All right, so we'll look at example number 3. All right, this is a good thing to know how to do. All right, so it says write an equation in slope-intercept form for the graph shown. All right, the y-intercept is 4. From 0, 4, you move down 1 unit and right 2 units to another point on the line. All right, all of that can be seen right here. All right, so our y-intercept is 4 because it intersects with the y-axis right here at the point 4, right? 1, 2, 3, 4. Okay, and you can see that because you start at 0 for your y value. Okay, and that's how that one works. All right, so we have 0, 4. 4 is our y-intercept. And then from here to get to our other point, right? So if we use this as our other point, you're going to do rise over run to find your slope. Okay, so m equals rise over run. All right, our rise from this point to our second point right here is -1, right? Because we go down 1. So -1 over 1, 2 is our run. So we have -1 over 2, all right, or -1/2. Okay, that is our slope. All right, so now we have our y-intercept is 4, and we have our slope is -1/2. We can use those, put them together. With y equals mx plus b, again, our y stays the same. Our m stands for slope, which we found out is -1/2. X stays the same. And then we add on our y-intercept, which is +4. All right, this is your equation for example number 3. Okay? All right, so that was it for that example 3. I want you to go ahead and try out these got it problems here. We have examples D and E, so go ahead and give them a try and see how they go for you. All right, here we are on, well, just right below that D and E example. All right, and I just want to look at what they have written here for interpret the y-intercept real quick. So It says when an equation is in slope-intercept form and it applies to a real-world situation, the slope represents the rate of change. All right, and then the y-intercept represents the initial value. All right, again, we talked a little bit in 3.3 about how slope and rate of change are actually the same thing. Okay, and then here we have y-intercept is the initial value. Okay, so the reason that is because for every y-intercept, your x value is 0. All right, so 0 would be like if our x value was time, 0 would be no time has passed, so that's where you're starting. Okay, so hopefully that makes a little bit of sense. Okay, so moving on, just below that, we're going to look at example 4. It is a word problem, just like what we just saw up above. So student council is selling t-shirts during Spirit Week. It costs $20 for the design and $5 to print each shirt. The cost y to print x shirts is given by y equals 5x plus 20. Graph y equals 5x plus 20 using the slope and y-intercept. All right, so step 1 they have is to find the slope in our y-intercept using y equals 5x plus 20. All right, so for this one, our slope is right here because it's m, right? If we were to write out y equals mx plus b again, you're just going to look for the same stuff. So m is 5, so our slope is going to be 5. All right, and then our y-intercept, b, is going to be 20. All right, so you can see that in the graph right here. They go ahead and plug those in. All right, I'm always going to go with my y-intercept first. I'm going to do that before I try to graph the slope. And the reason is it gives me a starting point. All right, so we start right there for b, for our y-intercept. And then from there, we're doing 5 over 1 is our rise over run. Okay, now you'll notice this looks like it's 1 over 1 for our rise over run, right? It looks like 1 and 1, but that is not the case, right? Because you have to notice that these have a difference of plus 5. All right, so it's going up 5. Down here, we're still going down, or we're still going up 1. Okay, so our rise over run is 5. So then we go up 5 over 1, and that gets us to this point. We can do the same thing, so up 5 over 1, that gets us to this point. Now that we have 3 points, it's safe to go ahead and graph and just make sure it's a straight line all the way through it. All right. So that is it for that example. All right, and then I am going to go ahead and have you do on the next page, so page 202, you're going to do got it problems F and G. All right, so for F, all you got to do is graph it using this. All right, and then for G, you're going to interpret the slope and the y-intercept. All right, so you're basically just going to tell me what is the slope, what is the y-intercept. That's all I need for that one. All right, once you've done that, you are good to go on this video lesson. Make sure you get these all taken care of, written down. The examples are all done so that you are prepared to go when we get back into class. And I will see you guys then.